All right. So, welcome to day 3 of VR Bootcamp. Today we're going to be doing basics of scripting. So we're going to be writing our first line of code today, and it's going to be very simple. And yep, today you're actually going to learn just what makes this actually a programming environment. So far we've been kind of using it more like a design tool, which also works very well, and it's very fun to do that with as well. But understanding just a little bit of these concepts is going to go a long way with helping you create your own projects, and also with working with already existing assets and stuff. You'll understand a little bit better how they work. But yeah, you'll learn all the basic Unity scripting components, concepts, how to create custom components, and how game objects interact with each other. Because that's what makes an interactive app, an interactive game. It's like, how do these 3D objects now talk to each other and get to interact with each other? Before we go on and do the homework stuff, I am just gonna again reiterate, it's just good to keep your projects orderly. So, you know, grab all your materials and stuff, put them in a materials folder, because we're going to be creating more assets and stuff, and we just want to, you know, keep things clean. And we can clean this up even more, but at least the materials for now, just to put them in there. But yeah, other than that, let's go ahead and do our little like homework presentations. So who wants to go first? Wanna go first? All right, pick you. Oh, just if you just connect to the VR Bootcamp one that I created. Does your computer have battery? You could kind of just, or do you need to be plugged in always?
Oh no, okay. Yeah, it's got some battery.
If you do you have yours up already?
No, it's on this flash drive. I just downloaded it onto the desktop. But should I create a new project and load the scene, or just double click on the scene?
Yeah, create a new project and then open that folder with it.
Import it.
Did you wait? Well, let me see how did you export it? So let me see. Yeah, so that's your whole project. So when you copy just literally the whole folder, you just go to your Unity and you open a new project. You go to Unity, open project, and then you go in there and then you open. And when you find the folder, the specific folder, you just click the top level and you open it, and then it'll do its thing.
Which one? The Bootcamp one?
VR Bootcamp, is it there? Let me see. Oh shit, okay. Check now. I don't know why it turns itself off. Maybe because no one was using it. Isn't that an amazing feature? I just Ethernet to my computer and hotspot to everyone else. VR Bootcamp.
Did you put the Slack with it?
Oh yeah, sorry about that. Let me do that right now.
You just loaded something completely empty.
Well, no, in the folder that you opened.
Yeah.
You open the assets. Just check in there. Maybe there's a double folder or something. So I'm gonna call this VR Bootcamp Day 2 tests.
I just opened the single scene in the folder and I see it.
Ready? So yeah, just bring your laptop over here. And
Restarting for some reason.
oh, that's okay. So if you did your homework and stuff, just have it open on your laptop, and then we'll put it up on the projector for a little bit. I want to see everyone's on. You ready? Yeah. So bring it over here.
Yeah.
All right, and I will be uploading this to Slack. Yeah, so just put it right here. And yeah, for anyone that needs this project that I have right here, it's uploading to Slack right now. So it should be right here in the general.
Open a new project?
So yeah, I would recommend you open a new project and then you just double click that package to import everything. Actually, well, before you double click it, switch to iPhone or whatever your platform is going to be. So I'll show you in a sec. So yeah, so we're gonna just open a new project and download it, but don't import yet. Do you have HDMI? Do you have? Are you the DisplayPort thing?
That's not my computer.
Do you have this thing? This thing?
Yeah, it's gotta have Firewire on it. No. Or Thunderbolt. No.
Yeah.
Wrong again.
No, it's
Cool.
it's supposed to be that, right?
Yeah.
Will it work though? Macintoshing.
Macintoshing?
Macintoshing. There we go. Nice. All right. So yeah, man. So
Alright.
just make sure you do maximize on play. Are you all good?
Yeah.
Yeah. And then just
Is it on?
yeah, it is. And then
Alright. So I made a little mushroom forest.
Yeah. Wow.
Got some bad rock in it. Make it around. You can jump.
over there.
Oh shit, I should have physics with me, I guess. Yeah, this whole layout, the whole landscape, it was an asset I downloaded. It came with the walk function and the jump function and all of the look controls. I guess the look controls already included in my preview for watching it.
Yep.
And then I took the scripts that Philip made, all of them. I used the audio beta one, obviously, and then I mapped, or I dragged the audio, rotate, scale, and animate to a couple different ones. This mushroom right here isn't doing anything. I'll probably change that. So yeah, some of them they're rotating on all different axes, and some of them are shrinking to the music. I mixed it up, and then just like pretty much copy and pasted mushrooms everywhere with the properties that I already gave them.
I like it. It's very tricky.
Cool.
Nice.
And then I'll probably add some trees, like going back and forth, something like that. Yeah, that's it.
Did you try the color one? The color to sound?
No, I was thinking about that also.
Yeah.
I'm interested to see how they change color since they're already, I don't know, color.
Awesome. So who wants to go next? You wanna go next?
Sure.
Yeah, so just plug yourself in right there. It's good to see you. So yeah, just you wanna help him? So just he needs to open a new project and import that Unity package. But I don't want him to import the Unity package before switching to iOS. So you have to go to the. Or are you doing? Which one are you doing? I mean, which one are you doing?
No. This is just my phone, but
Yeah, you definitely have those. You probably don't have any of the Android ones. You didn't do any.
Alright, show us then.
Yeah. So you go to show them so that build settings.
Wait, you want to import first, or you want to?
So no, first switch platform and then import. Yeah.
Yeah, so for that you go to.
Yep. So make sure you do maximize on play. And is the sound gonna come through?
It'll come through the speakers.
No, it's coming through.
Oh,
It's going through the projector.
Oh,
Yes.
cool.
Yeah, so go for it.
Okay.
You got the fat Elvis.
Yeah.
Too.
Yeah, this is I just have a couple of assets, some grandmas and an Elvis, and a couple different animation cycles. They both have different ones. Yep, okay.
Yes, so just press play and.
Okay.
Nice.
Yes.
About it.
I wanted to watch more of that. Oh, I just stopped it so early. Teased. Anyone else? Come on. You can sit it. You can
Yeah,
show
that's home. Is that the day of homework there?
Yeah.
That's fine. You made it, you modeled it
Is
yourself.
that your homework? Do you know that one?
Using the scale to animate things?
Dude, put everything.
Yeah, just bring it over here.
What are yours? I didn't do it. I didn't know. Sunday. But I'd be curious. Does that move? Does it play?
Kind of. I mean, I lost some of it. I forgot to save it. But
Yeah, that's stage two.
Somehow I can't play this.
Was it fun to make that?
Yeah, I got a little frustrated at first, but then I just like stayed at it for another hour or two.
That's usually how it is. It's like,
And then I was really happy.
yeah, pretty much. Like,
I mean, somehow I can't play with my laptop. It just keeps freezing right now. But I worked on this at my work computer. It was just fine, playing fine, everything. But somehow I can't play.
did you make a character too?
No, I downloaded from somewhere, and actually I spent time on it. Actually,
Yeah,
modeling.
use right click and then
right.
WASD. Hold right click.
All right. Huh.
Hold right click. Is your right click like some weird bind?
I don't know. Something got messed up. Really.
Did you right click?
Maybe
Like-
here. I use this one.
Yeah, man. Yeah. You changed your right click to something else.
I don't know what happened, really. Anyway, so I spent time on really modeling the space. So, yeah. I can't really show anything.
That's okay. Well, on the third weekend, we'll be doing be teaching polishing and lighting and stuff.
Mhm.
So you'll see how you could take this scene and make it look really really beautiful with good lighting. So that's pretty good. Anyone else? Yeah. You want to go next? Oh, that's great. What problem? Just that you said the sound.
I wasn't able to have her track
Oh, well, because you have to put, yeah, okay, I see what you're trying to do. You have to put the script on a specific body part.
That's what I did. I'll show you later.
Yeah, just you want to make sure she has the audio data in the right place.
How do you do full screen?
So all you have to do is here in the game, you have to have this set to maximize on play. Or are you doing it in here, full screen? Or in the game view?
I guess here.
Yeah, so just, this is fine.
Okay.
You can't really, I mean, I know there's a way, but I forget how to do it right now. It's like Alt-Enter or something.
Oops.
Oh, wait, what
Not
happened?
it.
Oh, you have it, yeah, sorry. Turn off maximize on play. Yeah, go for it.
So, I didn't understand how to
make the guy not appear right away.
Okay.
So I had to hide him. And instead I moved the smoke away from the boat.
Coming out of the bar.
And then I had lost some animations because I forgot to save it, but like the spheres were kind of like moving around. That's it.
Pretty cool, man. I love the Nebula. I'm a huge Nebula fan.
Yeah, it was pretty cool. I like the background environments that they had.
How are you doing the light? Are the colors changing on this?
Huh?
Is the color changing on this?
So, it's pretty like red.
Yeah.
It's like 4 colors.
Yeah.
And then it's like your and then something else started changing colors. But I wanted the, you know, the balls like float around and
They do the animation. Yeah, dude, that's probably the way to do it. So, do the animation on the stuff. Nice.
Thanks.
Alright, that's great.
Thank you.
So yeah, anyone else? I believe she's getting hers fixed up. But yeah, so that was great. I always enjoy seeing people's music video interpretations and the songs they use and the characters they use and stuff. I feel like it speaks to your character a little bit. Everyone kind of has like their own thing that they like to show. So that's pretty cool. All right.
Boom, boom.
It's a character, so it's like the entire body is all kind of together.
You should put it on one of the body parts, on like
Well, the thing is, it's on
in the
it's on
bones.
The mesh.
No, don't put it on the mesh. You have to put it on the bones.
Oh, that's what it is. It's under the hips,
So
spine.
Oh, okay, got it.
Yeah.
Alright, so do you need to show hours?
oh yeah, sure. You're right. Yeah.
So what I was trying to do was trying to, part of the body.
Do you have HDMI or do you need this?
Yes,
I always bring one because I feel like.
yeah, thank you. Ooh.
Oh, you do have HDMI. What are you talking about? You're all good.
Oh, okay. Yeah, so what I was doing
Just give it a second.
was, trying to animate that.
That's so good. Is that like a open and close switch? Or
Yeah, it's nice.
That's great because I have to do this. So like, I always, where'd you get that?
You should
Oh,
talk
that.
to Carolina. She can probably hook you up with one.
Yeah, I want that.
Okay.
Yeah,
just-
fix the the resolution.
What's the best way? Tilting. That's better. So it's not anything adventurous at all. It's not very interesting, but so I couldn't get the body part moving, so I just kind of trying to figure out.
But it's like we're putting together a scene and stuff. So I mean, it's
Yeah. Oh, the same one.
it could be the same project but a different scene, maybe.
I actually created a new project just because I wanted to try everything
Yeah.
new, so I can recreate.
Nice. All right.
So just press play, I guess. Yeah.
Is it gonna maximize?
How do I maximize it?
So let's see over here. So this game view has a. So are we looking at it in here, or in here?
I was just looking here.
Okay. So then just this is fine then. Just make this. Oops. Just make this a little bigger. You want to just make the screen a little bigger. Over here, just gonna pull it. The whole Unity window.
Oh, I see.
Yeah.
So yeah.
You want to just move your head a little bit? It's on the projector. Oh yeah, the laptop.
City.
So what I wanted to do was having a fish coming out of the water with the music, but then I couldn't really find a fish
Fish
that. Yeah, so I just put the eyeballs in instead. Yeah, so.
You created the eyeballs from textures, right?
Yeah, from textures. I just got the sphere and then put the texture on it. And more than anything, I wanted to create like the scene type of thing. So see what I can do with the 3 different options.
Very cool. You should try some of the skyboxes too.
Skybox, that's what we were talking about. So what is a skybox? Ah.
So it's
Ladies and gentlemen.
it's we'll do a more in depth on skybox, but yeah, basically it does. You know, you could do clouds, or you could do something like around. You know, you could do like a different kind of city environment stuff. But we'll go over that stuff. There's ways you can make, you know, just your regular 360 photo into a skybox in Unity, and there's many different ways you can create like the whole outer area. But yeah, usually it's really good if you do a scene. It's usually good to have like a centerpiece of a scene, and then to have like an outer piece of a scene. So like your outer piece to be like further out. Like, oh wait, I'm gonna fix this. Yeah. So then your other scene piece would be further out, you know, and maybe you'd have like some larger elements, you know, further kind of out. And then when you're in here, you kind of feel like you're still kind of part of like this larger whole. It's just a typical technique that's used in many different real-time things. You kind of create your close-up scene where you are, and then you create like kind of like the far-away stuff, which usually is scaled very big, and it's just kind of like you can't ever reach it. It's just for looking. But yeah, so without further ado, we are going to get into our next section here, and we're even ahead of schedule, so that's good. So, you know, just have your project open, and what we're gonna do this time is we're going to create a new scene. So I'm just gonna go to here, file, new scene, and yeah, let's let everyone do that right now. So just create a new scene. It's gonna ask you if you want to save this or not. You know, you don't have to, and it should look like this. So just a blank scene. So so what I'm going to do is I'm going to do a little whiteboard thing right here. So remember how we had, you know, every object in Unity is a game object, right? And then every game object has these things called components, right? Now components dictate behaviors. Components could be things like, you know, rigid body. Components could be things like audio source. Components can be even things like, I don't know, like animators, etc. So these are all components. Now, all of these components come built in to Unity. So it's basically, you know, you could technically write, you know, if you're really good at programming and you go deep, you could write your own rigid body, you could write your own audio source. But the thing is Unity makes things simple for you to develop with, because there's honestly really only 1 or 2 good ways to do rigid body. So then they already did it for you, and the components are pretty much ready, and they have things like gravity, and they have things like mass. So you don't have to worry about, you know, having to design a whole physics engine, for example. It's just not necessary. It comes as part of the whole environment. Yeah. Okay. So Same thing with like audio source animator. So Unity already comes with a lot of different components, just kind of like normal everyday use things, like if we're doing physics or if we're doing audio and stuff. It's just kind of like, you know, cookie cutter stuff. Now, what happens when there is a behavior that we want to have, but it doesn't come as part of, you know, Unity's built-in stuff? Is this? Not working. So now these components, you may remember from the script that I gave you, the audio data stuff. So audio data is a component. Now audio data is a component that I created. It's just a script, and it's just called audio data. And now that becomes an audio data component. Now this name could be anything. This could be, you know, my funny script. And then the component would be called my funny script or whatever. So now, let's take it in theory here. We have two game objects, right? So we have one game object over here, and one game object over there. Now, each game object has the ability to have components, right? So picture it like this, you know, this game object has some components, this game object has some components. Now, when two game objects need to interact with each other, say this object collides with this game object, I want something to happen, for example. So the way that behaviors between game objects, the way they communicate, is through their components. So these components can have certain things that basically send data back and forth from one component to another. So not only can two game objects talk to each other through their components, but components can also talk to each other in the same game object as well. So just think of the component as like kind of like the actual behavioral part of the game object. Without a component, the game object is just a position in space, and maybe it has like a a 3D model or something like that. But it's just a static object. It doesn't do anything in your scene, doesn't animate, doesn't do anything. The moment you add a rigid body, boom, now it has a component. Now it's reacting with other, objects and stuff. Now think about it. If remember in the first lesson when we did rigid body. So what happens when one game object has a rigid body and another one doesn't? When they collide, goes through it. So the interaction doesn't happen. The only time the interaction happens is when they both have components that interact with each other. Now you don't actually have to tell each rigid body component to react with another rigid body component, because the way the rigid body just works, it just reacts with other rigid bodies. So it's a built-in Unity component that just kind of reacts with other components. But it illustrates kind of like how this communication between game objects happens. Now I'm just gonna lay this out even simpler than this. So this is just very high level that we're talking right now, but we're gonna get very practical right now. So now say I have like a specific scenario. So I have a ball, which is a game object, and I have like a goal post, which is also a game object, right? So I want this ball to go in here, and something should happen. So what will happen? The ball goes in here. I'm going to increment, the score, which is 0, is going to increment to 1, and then it's going to play like a sound. So there's going to be one component on here that moves the ball. So this is a component, and maybe we'll call it something like move ball. And I'll show you how we're going to create a component like that. So one component here is called move ball, and one component here is going to be called, something like detect ball. right? So this component moves the ball. This component detects the ball and changes this to 1 and plays the sound.
The components aren't just objects, they're also behaviors?
So components aren't objects. The game objects are objects. Components attach to game objects, kind of like, you know, a component can't exist on its own. It needs to be attached to what's called a game object.
It's a behavior or
It's basically a behavior, yes.
Okay.
So components give behaviors to game objects. So, you know, so for this demonstration, what we're going to do is we're just going to show a very, very simple interaction on just how, you know, on one end, you know, the first thing that we're going to do is I'm just going to show how you could do something like moving a game object based on input. So then the other thing too is, and that we don't think about, so the move ball, not only does it just move ball, but it also has to detect, you know, like a press or something like that. So on press, move ball, and then this is always listening, detect ball. So that's just a very, very high level overview. But you know, it doesn't matter if you do it in C# or in JavaScript or you use already built-in components and stuff. This is kind of like the general pattern that you make things in Unity. So you have these 3D objects, 2D objects, whatever objects you have in your scene, and whenever you want those objects to have a behavior, you want them to do something, you want them to detect something, you're probably going to need a component. Now that component, you know, maybe it already comes built into Unity if you just need something like a rigid body, or maybe you need something custom, like if you're making like a soccer game or something like that, you probably want like a very specific behavior. So let me show you how you make just a very simple component to start with. So So our empty scene, right? Let's just set our empty scene up just a little bit like how we did before. So game object, 3D object, plane. So we just make, you know, just a little plane. Take the plane and make it 0 position. So you know how when you click the 3D object, here on the right side of the inspector, you just have the X, Y, and Z position.
Why does
So
it not always load it to the origin?
it depends on where your camera is in the scene. That's kind of how it does it, yeah. So, and then we're gonna make this grass. So you should already have your grass in your materials folder. So just do this real quick, and we're just basically gonna set up our soccer field per se. They already have the grass texture.
I do, but you say before that, like
But yeah, so when you have an object click, this is its position in space, X, Y, and Z. So if you make those all 0, it will put it exactly at like the origin. And you don't actually have to make it 0, 0. I just think it's cool.
Are
Are you running a different version? Or is it just taking forever to air? You know, you can just start on your project. We're not even going to use most of those assets. I just wanted you to have it like basically run here on the here. Yeah, so just force quit it and just start on your project.
You still want it to be in iOS?
Yes. So now, before we get into the ball yet, I mean the goalie and stuff, what we're gonna do first is we're just gonna create a ball. So just game object, 3D object, sphere. If your sphere shows up like under the plane, it loves to do that sometimes. That just means it's under it, like that, so you could just pull it up. And just to be sure, you could always just make it also position of 0, 0, 0, and then it'll put it like right in the middle there. So let's just create our scene like this. We just need a sphere in the middle and grassy plain, and then we'll be ready to go to do our first interaction. If you don't have the grass texture, you just Google on it.
You want the sphere at 0 as well?
Yep. You know, and then when you put it at 0, it probably will be in the ground. So maybe just pull it out of the ground like that. So now we're gonna go ahead and create our first component, right? Now I'm gonna do something that I usually don't do at my classes, and I'm gonna show you both JavaScript and C# just for this first script, just so you can see the difference. But for the whole class, we're gonna be using C#. But just so I can so it can make a little bit more sense for this first one, I'll just show both, and then you could see what the difference really is. So, you know, let's start our first script by right-clicking here in the project, and then you go to Create and make a JavaScript. And now let's call this JavaScript Move Ball. Once you have your script, double-click it to open the script editor, and you should see something close to what I have, just like this. So yeah, to create a new script, you just create it in a project, right-click, create, and then JavaScript. And when you double click it, so yeah, just change the name. It should start already ready for you to rename it. And yeah, just open it up and start typing out your name. Now, if you're having Visual Studio open up, I recommend you don't use it. You just go to Unity. So just go to go to File, Edit, Preferences, and then External Tools, and then switch that to the built-in. Yeah, comes much quicker. Then you can just close it. Yes, if you don't see this, if you see Visual Studio, let me know. I can help you. Everyone's ready with their JavaScript? So, here's what we're gonna do, right? So, the first thing that we need, and you know, we actually don't need to really do it for this one right away, but you know, we'll get to the input in a second. But I want you to start typing like this. So, before we type anything, I just want you to understand exactly why we're using the specific words that we're going to use, right? So now, if I click the sphere here, you don't have to click this, just watch what I'm doing. Notice, so remember how whenever you have an object clicked in Unity, the right side is the inspector, and it shows you all the details about the object. So each thing here is a component, each of these like bars. So transform is also a component, but transform just comes with every game object just ready each time. Every game object has a position, so that means it has a transform. Now, if we wanted to move this ball, which component do we need to modify? The transform. Yep, transform position. So Can you guess what we're going to type in here? An update. Transform dot position. Oh god, it's not even doing autocomplete. I haven't done JavaScript in so long.
Why are you typing it after update?
So yeah, let me explain that too. But basically, everything that runs on start runs only once. Everything that runs in update runs every frame. So here I'm just going to do this. Transform dot position dot y. So if you just look at how we're breaking it down here, it's basically the transform component and then into the position and then into the specific number we want to edit, right? So transform dot position dot y is equal to transform dot position dot y plus 1. I hope this works. It's not auto completing on JavaScript is so long. It should. Like, it cannot not work. JavaScript is like, I know, right? I'd be really embarrassed if this doesn't work, but it should.
Are you doing 1 because you want less incremental change?
I'm basically incrementing by 1 here. So if you see what's happening here, so there's an easier way to do this obviously, but I'm just doing it in a very easily explainable way now. And I'll show you how the proper way to do this is though later. But so what we're doing here, we're taking the transform position dot y and we're making it equal to, which basically means you're changing its value to something new, and it's basically itself plus 1. So every frame, this will move up by 1. Now, if I just save this script, and then if I go back to Unity here, now grab my sphere and grab my JavaScript and just drag it here as a component, like that.
You can drag it onto the ball also, right?
You can also drag it onto the ball. I don't recommend you do that because sometimes you can misdrag things. You can also, the safest way is to drag straight into the hierarchy here in the name of the object. So it will probably go really fast. So if I press play right now, it will probably it's gone very fast, right? So how would we slow it down, right? Go over here, and instead of plus 1, let's do 0.1 this time. So we're not, because right, plus 1 was too fast. So if we want to make it slower, let's make it like a decimal. So it's not like a speed of 1, but it's a speed of 0.1 this time. Is anyone else getting autocomplete when they do this JavaScript, or is that's just JavaScript? Yeah, so that's, I guess, another reason why you should not use JavaScript. It does not have good, strong typing and stuff, but it's okay. This is just going to be very simple. So, everyone got this? Plus 1, plus 0.1 this time. So now if I press play, it's moving slower. See that?
How many frames per second is you run?
It depends on your computer. But that's a good question.
It's not like movies, it's not 32 frames per second.
No, I mean, it's, it depends on how fast your computer running. Like mine right now is rendering 1,700. It was like, it's at 100 frames per second. It tries to limit itself, but it goes even up to like 1,000. But they're lost frames. They don't really do anything. So that was pretty easy, right? Just a small, simple behavior, one line of code, move an object up. Now let me show you another cool trick. So how we're changing this number here, right? This 0.1. We're doing it manually. We're going into the script and we're literally changing like the number straight in there. Now, if you go up here outside of these functions, we're going to create something that's called a public variable, right? So type like this: public var speed is equal to 0.1. Now, variables are just like what we did in elementary school math. You have, solve for x, solve for y. So a variable is like think of it like a placeholder. So when I do speed, variable speed is equal to 0.1. Now, over here where I do plus 0.1, now I can just do plus speed. Okay, so do that. Because you defined speed at the beginning of your program here as 0.1, whenever you write speed in the rest of your program here, it will know that that means 0.1. Makes sense, right?
Can the word speed be changed to anything?
Yep, it could be my speed, or it could be crack cocaine speed. But yeah, let's just make it my speed, or like,
In case you have like two different objects going at different rates.
Breaking Bad speed.
Do you need the word speed, or can it be any?
We're just writing it speed because it's going to be speed, yeah. But yeah, it's a good exercise to put some funny words as variable names, because I see a lot of people sometimes get confused between the official words in a program and the words that you make up. So yeah, that's a word that you can make up basically. It just it's good to name it something that's relevant. I see a lot of people that are beginners, they just name everything test 1, test 2, test 5, and then after you get a few of those, it's kind of hard to figure out what's what. So now, if I go back to my script, it should still work, even if it's just moving up by the speed increment. Now, the only thing that actually changed was because we defined this public variable here. When something is public, very important, it becomes exposed to the rest of the program and to other game objects. So if another game object wants to modify speed, speed needs to be public. So if that doesn't make sense, basically what that means is think of every script, like this script, as a self-contained unit. So everything in that script only belongs to that script, and only the script inside it can see those things, unless you define something as public. When something becomes public, that means that another sphere can check or can change that speed. Another thing that happens when you make something public like this is when you go back here into Unity, and if you click the sphere now, notice our little component has a little field right here. You see that? Look at that, right? That we can edit straight from Unity. So this is what a component is, right? So you just created a very simple component. And now if I press play and it moves up, see, if I change this in runtime, I make it negative 0.1, it will come back down. See that? Or I can change this and make it even more incremental, like 0.01, and then make it go up even slower without editing my code now. See?
Actually updating the code too.
So it's, yes, so basically you're updating the variable. The code still stays the same, but because speed is defined in here, and if you change speed, then yes, your code also gets updated. So now I think you can kind of understand what I mean by creating your own component, and how all the things in Unity are components. You notice when you're tweaking things, see all these things. So those are already built for you, and they're made public. The sphere collider has a radius, and that's a radius, that's a value that you probably want to change. So then they made radius public, and then now you could just go in and change the radius of a sphere collider. Same as our move ball script, we made our speed public so that we could change the speed from our editor here, and we don't have to go back in here and do it. A great thing that this is useful for is if you're incrementing in many different places, you don't want to have to change speed in 5 different places. You could just change speed in one place and all the other places also update. So now this is not Unity specific at all. This is just very, very basic level programming. So you already know a decent amount. Even public and stuff is already entering into the specifics of programming.
Can I ask you a question?
Sure.
So if you create another script, can you just use speed?
You need to define speed in the other script as well. Yes. So every script, think of it, it's a self-contained unit. Now, there's a little trick here, and this is so. It's a little bit more of a computer science lesson, but it's good to know how this stuff works. So, did you notice when we made it, when the speed was 1 here, that it went like really fast? Now, this means by when you put like 1, so you're moving the transform position by 1, right? So now notice when I move by 1, so how much is 1? So right now I'm at 0.52. If I move it up to like 1.52, that's 1. Okay? So it's usually like this the radius, or like the diameter, right? The diameter of one of these spheres, like a basic Unity sphere, is usually a unit of 1. Unity says it that like the equivalent of 1 is like 1 meter, like approximately like a little bit over 1 yard in the virtual world here, as it is like in the real world. But when we had the speed at 1, now remember, update happens once per frame. Now, in the animation world, in order to create an animation, you need to combine multiple stills. So it's like 60 still images make an animation over the course of 1 second. So when something is running at 60 frames per second, which is usually like the right amount, that's when you can see like the animation happen. Now, since we were doing a speed of 1 every frame, that means we moved 60 units in 1 second. That's why it went so fast. Does that make sense? So, since it's every frame, and there's 60 frames in a second, that script ran this so many times, so fast, that's why it moved like really fast like that. Whereas like 1, you'd think like 1 is like, you know, it's a slow number. A speed of 1 shouldn't like be like rocket speed. Now, incrementing things like the movement of an object by like a rough number, like 1, like that for example, is actually not the best way to program your computer code. Here's why. So in today's world and how we're doing, you know, VR and how we're doing, you know, all of our apps pretty much, everyone's running, you know, a different kind of phone, different, you know, CPU in there, different amount of RAM. So basically, you know, my computer and someone else's computer, they perform at different speeds. So my CPU, it's an Intel Core i7, will probably, you know, have 3 or 4 times the performance of like a, I don't know, like an Intel Atom, or I don't know what's in like a MacBook Air, for example.
Fuck you.
But I'm getting to a point, right?
Here, man.
No, I'm sure. But your code should not move the sphere faster on an Intel i7 than an Intel Atom. It doesn't matter if it's an Intel Atom or Intel i7. They both can still move a sphere, no problem. It's just definitely, like if we measured it, like with this code that we have right now, my sphere would be like way up there, like further than like what an Intel Atom's would be, for example. Now, that's obviously not the right way to do things, and there is some features that you can use to actually do something what's called to normalize, like across the different hardwares. So back in the day, you know, when you had like Nintendo and when you had PlayStation was really popular, like, and I'm sure they still are, but people that coded, they coded like this. So it was very like, not like this. I mean, they weren't doing JavaScript. They were doing assembly language that was like very like, it was practically like, binary code people were doing back then. But, the same Nintendo that you worked in the lab was the same Nintendo that the kid had at home. So there was no difference in CPU speed. So people that coded these games or these apps ran the same across all the different hardwares. So people never had to really worry about that. And that's why you also saw a lot of times console games looked better than PC games with weaker hardware specs. And the reason is because they were able to tweak things very specifically to the console, whereas on PC, you kind of have no idea what you're going to get. You don't know what graphics card there is. You don't know what CPU there's going to be. Good news is that there are some features that we could use today to normalize across these kinds of devices. So what we're going to do here is I'm actually going to change the speed back to 1. And I can change it back to 1 here too. It doesn't matter, but change it to 1. Now, I'm doing transform position.y plus speed. What I'm going to do with speed, I'm going to multiply it by a special built-in function called time delta time. And it's spelled exactly like this. So time big and then dot delta time. Now, everything inside the time class, you can already imagine what it does. It deals with time. Now, let me explain what delta time is, right? So delta time is basically the number that checks, kind of like your CPU's frame rendering speed. So my delta time will probably be smaller than like a lower performing computer's delta time. But basically what that does is it keeps things the same no matter how fast your computer is running or how slow it's running. If you have a really choppy, like laggy experience, the character still should move 10 steps when you press the button 10 times. Instead of, because the computer is taking so long to load the next frame, maybe it skips a movement or something like that. But again, just to make this simple, time delta time, what that does is it basically accounts for all the different speeds that different hardwares have. Now, again, I'm going to bring it to elementary school math here, and it's good to get a refresher on this. Order of operations. Does everyone remember that, right? So times happens first, and then addition, right? Even though I have addition plus speed times this, if we have 1 plus 1 times 2, what's that equal to?
3.
It's not 4. I don't want anyone thinking it's 4. It's not 4, right? It's 3. Because 1 times 2 is 2, plus 1 is 3. It's not 1 plus 1 is 2 times 2 is 4. That's not how mathematics works. And that's not how the computer does it either, right? Everyone remember that?
Yeah.
So it actually mattered when you learned this in school. It actually had importance.
But if you use the quote,
If you use parentheses, that works as well. Yeah. So if you do the parentheses, then yes, parentheses first, and then that equals to 4.
what is the order like for division and subtraction?
Just like mathematics.
I never learned that.
I'm pretty sure you did. I'm pretty sure.
It's multiply, divide, add, subtract.
No, it's
In that order.
multiply and divide. They both happen like there's no preference between multiply and divide. Okay.
Okay. I never thought about that.
You fail elementary school math, but it's okay. No one feel bad, please, about this. It's good to see how much we actually forgot of this stuff is important.
Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction.
Yeah.
But multiplication and division, they kind of, you know, there's no real order to them. Like if you just multiply, add numbers.
Multiplication, division, addition, subtraction.
Exactly. Yep.
Just two sets.
Yep. So that's exactly how it works, and that's exactly how it works on the CPU. It's exactly how it works in any programming language as well. So the time delta time is only affecting the speed, not the transform position, not y. If we multiplied this by the actual transform position, it would mess it up. It would do God knows what. It was not exactly what you should be doing. But yeah, so just so you realize what's happening here, this is happening. It's basically the same as It's basically the same as doing this. But you don't even have to do that because it's multiplication. It already automatically does multiplication first, and then it does addition. So, you know, now that we have times time delta time, and now it's speed of 1, remember, it's not 0.1 anymore, or 0.01. If I go back in here and I press play, it'll move pretty slow, because it's now accounting for the speed of the processor. So speed of 1 is actually becoming a speed of 1, which it's basically moving 1 unit space in the world in 1 second. That's basically what that becomes when you multiply by time delta time. So if you have 5 here, you will move a speed of 5 per second. Does that make sense?
What's the delta time?
So again, like if we just delta time just basically kind of I believe exactly what it does is it calculates the amount of milliseconds it takes for 1 frame to render. So that's basically what it does, yeah. And it just normalizes everything to 1 second. So whenever you're adding by something multiplied by time delta time, it's basically like if you're adding by 5 times time delta time, that's basically 5 per second, basically, if you're doing it every frame. But again, don't get too caught up in these semantics and stuff. I just want you to kind of just have fun writing your first little script here.
Is that way you do it all the time? So whenever you just speed up any time, you always do the times.
Specifically when you're doing it on updates. So if you're just literally updating something every frame, like, and you notice it just flew out of the scene for like some very small number, it's probably because it's doing it way too often. So like, you know, moving a speed of 1 60 times a second is technically a speed of 60. You get it? So yeah. But again, let's not get too caught up in the time delta stuff. Now, what I want to show you is another simple programming feature, and you've probably heard of this. If let's start typing this. If, so it's right above this transform position. So you write if, open parentheses. Now everything that's inside of parentheses after an if is basically the if what, you know, if and then what. Okay, so if input dot get mouse button down. Actually, just get mouse button, just like this. Open another parentheses, and then put 0. Close that parentheses, and then close another parentheses. So you can already kind of imagine what this does. But basically what happens here is you get if the left mouse button is clicked. 0 equals left mouse button. 1 is right mouse button. And you have 2 and 3 and for your weird middle mouse button, and depends on how many mouse buttons you have. But yes,
How much does capitals matter in this?
it's strong typed, so you have to capitalize just like this. So usually it's the first word, the first letter of the word is capitalized like that when you're writing functions. And I'll show you exactly where, you know, you can find this terminology and know that you're using the exact right terminology. So now, if you just save this script and you go back in here, you'll notice that your ball will only move when you hold left click. Now if it's not moving, it's probably because you're not clicking in the game view. So you have to click here, right? Click and hold. The reason why you have to click in the game view, because this is technically your program. So this is, in here is where your actual events and stuff gets fired. So I'm just gonna put this script up like this, and yeah, let me just see everyone doing that. So press play, and then you should just be able to hold. Get, not again. You misspelled get. It's a get. Yeah. But you'll see when we switch to C#, it auto completes for you, and it tells you, you know, JavaScript is kind of messy. Good. And you know, if you change the speed and whatnot in a component, then obviously, you know, and you know, for bonus, you can try to make the speed negative, and then see it go down. So you click the sphere that has a component, and there it is. And so you have two. So you might want to get rid of one of the components by right clicking the name. So usually right click the but even having two, you have to do that. Yeah. So it works even if you have multiple components of the same type on one.
Negative, it should go down.
Yep. Now, the reason why that negative might not be changing there is because since it's public. Now, if you go back to Unity, you'll notice that you have to actually change it on your sphere in there. So you have to click the sphere, and you have to change it in there, -5, because now you've exposed it. You know what I mean? So now changing it back in there is just kind of like the default. But that's where it actually now gets stored. Yeah. Yeah, it takes priority there now.
Wait, so if you put it on the script because it's public, right? So
yeah,
help me to understand. So when public is negative and it doesn't have the same effect for what reason?
Oh, I'm just saying, like, since when you make something public there,
Right.
and now if you change that number, you'll notice that, you know, whatever you put there, if you go back here, it won't change it in there, just because the inspector takes priority on it just basically takes control of those public variables. Now the only time it will actually show this number that you put in here in the script is the first time you load the script. It will use that's like the default. You know what I mean? But then you're changing what it currently is in here. So it doesn't matter what you change the default over there, until you change it in here, it won't actually change for the specific instance. You know what I mean? It's like when you write it in the script, just like the specific number, you don't even have to put a number. You can just do public var speed, semicolon, you know, and then set it in here. That's just the default that you start with, basically. And the only time that will be the same is when you first pull the script in.
So let's say if I make this as a negative, I think I understand. But
Yeah, so you have to make it. You have to make sure it's here. Yeah, if you change it there, I mean now since they're the same, But
right. So let's say press play, and
you have to click in there.
there's a negative number, and now all right. So it makes no difference.
Well, it's basically this takes priority. So what happens here? This doesn't matter as much anymore. That's just the first initial number it starts with.
So that's like the foundation of what speed is, and
Yeah.
then you can tweak it.
And then you
for
tweak it later in
objects.
the inspector, and then it makes sure to remember what you did in the inspector.
And you were able to change in inspector because you made it in public.
Exactly.
Okay.
Yep. You'll notice if you get rid of the public, it won't show up in the inspector anymore. And then it does matter if you change it in there. So, very simple, right? Now, what I'm going to do here is, some of you might not like this, but it's good for you. We're going to ditch JavaScript. So I want you to just close this.
Isn't it written exactly the same?
What?
It's written exactly the same as this.
It's easier, I feel like.
You can just copy and paste that, right?
No, it won't
No,
work
it's
like that.
different about it.
You can't modify like the
Oh, yeah.
.y. You have to store it in another. Yeah, and then you can't just do public var speed. You have to like define that it's a float and stuff. So now let's get into some real programming now. But like I kind of showed you, yeah. So this is like I feel like this is a good example to just kind of show you how this stuff works. Also, just as a quick note, the Unity script reference is your friend. So say I just Google, move transform Unity. First thing that shows up is the scripting API, and it's showing you a transform translate function, transform position function. If you just click any of those, right there, you have code snippets ready to copy and paste, both in JavaScript and in C#. So you're going to be spending an awful lot of time with the script reference and with looking up a lot of this stuff. I didn't know almost any of the syntax even a few years into doing Unity. I knew what I wanted to do, like to move a transform. I didn't know exactly what the wording was, so I just looked it up, and then you get the code snippet, and then you use that, you modify it. So that's totally fine. No one expects you to remember even like a majority of the syntax, even close, until like you're already a few years in and you've typed it so many times that you just remember it. I've typed it so many times that I just remember it now. But like I said, when I first started out and even a few years in, I was still looking stuff up. There's no shame in it. It's actually better. You free your mind from having to to remember the tedious stuff. The important thing is to understand the concept of what you're doing. So far, now you understand what this transform really is here. So far we've been playing with it like this, and we've been playing with it in here, but now you can see how how one component can talk to that other component and change its value, and that's what actually makes an object move in a scene. So this time we're going to create another type of script. So just right click here in the project, create C# script. Now before you just let it rename itself there, just rename it while it's still blue like that. I'll explain why. And just call this move ball. Same thing. The first name you give your C# script is the name that the class gets inside the script. So if you just
name it the exact same thing as the first one.
Yeah, so they the exact same thing, yeah. They won't conflict. So because they're JavaScript and C#, so they basically don't see each other. But they actually work together. You could have a JavaScript on one object and a C# on another. You could have a JavaScript and a C# on one object. They just can't access values from each other. So what Unity does for you is when you create a C# script, whatever name you give it, if it just gave it new behavior script or whatever, this would be new behavior script in here, just so you know. If you ever rename your script after the fact, like let's say I just called it move ball, maybe I made a typo or something, and I'm like, oh, I'm just going to rename it. And I rename, move ball, move or whatever. Now it'll probably give me an error if I try to pull it on here. See, can't add because the script cannot be found. The script class cannot be found. The important thing is that the name of the file has to be the same name as the class here. So because my class is moveBall, but my file name is like mob or whatever, it won't work. So they have to be the same. And they always will be the same when you just create the script, and if you name it right away, that's what you get in your template here. This is your starter file. So for every script that you make, it will always kind of open up like this. And now you can notice the similarity, right? So It has a start, as an update, just like JavaScript. The only difference is you got a few of these extra doohickeys over here, and you got this whole like business curly brackets over here. So again, you probably will not have to worry about any of this. For the most part, we're working in here, just like how we were in JavaScript earlier. So just this initial first void start, void update here.
Well, if you did want to rename it, would you rename it within the script?
Yes, you have. If you rename the C# script,
Yeah.
you should definitely name it. The class has to be exactly the same
Oh, so you'd have to do it in
as the
both
file
places.
name. Yeah. If you end up renaming, yeah. If you just name it the right thing in the beginning, then it'll just do it automatically. Okay. So now what we're going to do is we're going to write that same exact script, but we're going to write it in C#. So let's start with the differences, right? So notice how, and I'm going to open the JavaScript just for comparison right now. So here it says function start, function update. In C# it says void start, void update. So for all intents and purposes, void is the equivalent to function. The reason why it's called void is just like a programming thing. It basically means it has no return. It's a null and void return. It just executes. It doesn't bring anything back. That's a high level programming concept. You don't have to understand what that means. But if you just want to know, why it's void, that's why. But basically, for all intents and purposes, it's the same as function for what we're doing. So treat void start, void update, just like you treated it here. Function update, function start, same thing. The other thing, again, obviously everything's inside a class. So again, you won't have to modify this for the most part unless you're renaming things. But basically, everything about this script currently is running inside this class. Now this colon here, where it says mono behavior, again, you don't have to worry about any of this stuff, but I'm just explaining what it is. This basically means that this script is a type of mono behavior, which is basically what the language is called that makes behaviors in Unity. Everything is built in mono, and every behavior is a mono behavior. And what this does is it just already sets that up for you. So every time you're going to write any kind of component, any kind of behavior, it's going to be in this template.
So when we were going over JavaScript, we had a public class.
Mhm.
where it was only-
I know we haven't written it yet, so
Right, but then that created a variable field in the script.
yeah.
But then now everything is within the public class.
Because now the script itself is in C#. The whole class has to be public in order for it to work as a behavior. So JavaScript, you can almost imagine that this also had public class all the way around this. The reason why it doesn't is because it's JavaScript and it doesn't care. Like, it just assumes that things. So that's one of the main differences. Is in C# things are specific. They're written specifically. In JavaScript, it's more forgiving. It just kind of like, it lets you make a mistake or two. It lets you, like, not have to make things public when they actually are public. It just assumes certain things. It's made to be like more of a starter language. So like I said, it's more forgiving. So again, don't worry about this. What this basically means is pretty much it'll show up there. That's why the whole thing is public, because it literally shows up here. So that's the whole script shows up there. That's why it has to be public. That's what it means, if you're just wondering what that means. But again, don't get inundated with any of this stuff. Just, if some of this stuff doesn't make sense, just ignore it completely and just follow along with the parts when I'm like, all right, now pay attention. Like, this is important. The other stuff, I'm just kind of like just covering some cool stuff that I feel like it's important to know, but it's not necessary to know. So now let's try to write that same script, but with C# this time, right? So here in update, make a, type enter a few times just to give yourself some space here, some breathing room. So we're not all like crowded in here. And you're going to write the same thing. You're going to write transform position. Now keyword, we're going to try to write the same thing, right? And you're going to see how this works, right? Transform.position.y. You can honestly even copy it from here, if you want to be lazy. Or you type transform.position.y is equal to transform.position.y plus 1. Something like that. Same thing we did before, right? So just type that, save, and let's see the error we get. So yeah, just do that. I'll just keep that up for another few seconds. Another important part about what you're going to learn today is you're going to learn how to debug. So this is very important in Unity to learn the error messages that it gives you. They're very descriptive and they're going to help you a lot with your project. Usually you could just make a simple mistake or something, but if you read the error, it'll tell you exactly what's wrong with it. So if I just type this, I go back here, you can see I already have an error. Errors show up on the bottom here in red. And if you want to see more errors, you can click console. And console is basically all the messages that are coming out from your program, including errors, warnings, whatnot. So console can always be accessed from here, from project console. Now, if I look at the error, it's going to write this weird, cannot modify a value type return value of Unity engine transform position. Mouthful, right? But that part doesn't matter as much. The part that really is plain English and maybe we can understand it is consider storing the value in a temporary variable. Now, let me explain what this means. So, what this basically means is in C# you can't just go in and modify just the y of a transform position. It just doesn't let you do that. It used to, like 3 or 4 years ago, and then they decided that that's not fast enough and that you shouldn't be doing it like that. So the reason why is because the way that you actually are supposed to give a transform position is you're actually supposed to do the whole transform position like this is equal to a new vector 3, and that is an x of y, a 1 here, a 0, or something like that. But in reality, what we're actually going to do here is instead of that 1, we're going to do like that. Okay, so I'm just going to go over that again. So transform dot position is equal to new vector 3, open parentheses, 0 for x, transform dot position dot y plus 1 for y, and 0 for z. Now, there is an easier way to do this in C#, but I'm just trying to write literally the same style of code that we wrote earlier, which you can see can be a very inefficient way of doing it. But we're just doing this for demonstration purposes. I'm going to show you, on the final part of this, I'm going to show you how you actually do the right way to transform in a very simple one-line way. So, now I'm going to explain real quick what that blue vector 3 thing is, right? So, remember how we had our game object, right? And a transform as a component, right? What does the transform have? Transform has position, right? Rotation and scale. Everyone remember this, right? Now, how does this look in the program? You have what? X, Y, Z, right? All of these are X, Y, Z. Now, Unity has a built-in, what's called a type vector 3. three vectors, x, y, and z. That's what vector 3 means. So vector 3 is a special type of variable that stores x, y, and z coordinates, basically. So you're going to be working with vector 3s a lot when you're doing things in positional scale, when you're doing things in Unity, you're moving stuff around and stuff. So in vector 3, again, it always goes x, y, and z. So you have, this is x, that's y, and that's z, separated by a comma. So vector 3 always looks like this. So, vector 3, and then in there is your x, y, and z. Okay? Now, another thing that you have to do here before this actually works. So, now, before we save this second line, comment it. So the way that you comment something is you do 2 forward slashes in front of it, and you can see it gets grayed out like that. And what that basically means is it will no longer run in your code. You just kind of keep it there, like a comment. So you can use comments to give yourself notes. You can use comments to disable certain lines of code until you're on them again, or you modify them and stuff. So let's just comment that out. And let's save this, and now let's look at the next error that we get. If I go in here, is it gonna be a main error? Let's see. So you click your sphere. Let's get rid of the JavaScript move ball, and let's put our C# move ball this time. Is it actually gonna move? It does move. Huh, you don't have to do the F thing anymore? You don't have to do the F thing anymore. Cool. I feel like you're going to have to do it later. Well, in any case, usually what you had to do is you couldn't just do +1. You had to be +1F. Now, let me explain what a 1F is, or what any number F is. I don't know, it worked even without it. But so now, as opposed to JavaScript, in C# you have to be very specific with what types of numbers you're working with. Now, since we are doing like a completely beginner course, and this is your intro to programming basically, I'm just going to explain a few of these basic values. So again, we kind of covered like the basic elementary school math again, because it all kind of comes back down to that elementary school math. So when you have numbers, you can have whole numbers, right? Integers, so like 1, 2, 3, 4, right? Then you can have decimals. You have 0.1, 0.235, 0.67, 0.87, or whatever. Now, something that's a decimal, a decimal of 1.0 is basically the same as 1. Now, the difference being in programming is that your program has to know that something it is either a whole number or is a decimal. It can't be one or the other. It has to be one or the other, basically. Now let me explain what that means. So let's just do like a little case scenario. So for example, when we have like a score that we want to keep, right? Our score is 0, and we increment it. So score a goal, now your score is 1. Score another one, now your score is 2. Your score can never be 1.5. Okay, if you live in some weird world and that's how you want to make your game, sure. But if you try to do something like keeping score, keeping like coins, keeping amount of enemies killed, there's no 1.5 enemy killed. It's 1 or 2 enemies. Right? Make sense? So for those types of scenarios, you're going to use whole numbers, which are called integers. So everyone remember that word? Integer? Short for int in programming. Decimals, on the other hand, are in programming called float for the most part. Now, you can use actual decimals, but we're not actually using real decimals. We're using something even more advanced than a decimal. It's called a floating point number. Now, what a floating point number is it basically, it can be so precise that it can go, down like, I don't know how many, but it can go a lot, a lot of precision points. Now, for things like movement, right? Now remember when we move our sphere doesn't move as integers. Sphere doesn't go from world 1, then 2, then 3, because then it would look like it's teleporting, right? A sphere is animating. So you're incrementing by a decimal, basically, by a float. Now that incrementation, depending on the speed, could be very tiny. So your sphere in one frame is 0.00001 in y, and the next frame is 0.00025, and the next frame is like 0.35. So again, when you're working with those kinds of things like movement and stuff, where they're not rounded numbers. They can be like anything in between, basically. You're going to be working with something that's a float. Now, one way to say that a number is a float in C# is just to put the little lowercase f next to it. So if you ever see that, that's what that is. Just so you don't get confused what the f means. Basically says that number is a float. So, does anyone have any questions, by the way? So I'll get in deeper in this. This is just, again, high-level overview, a little bit. But what I'm trying to get at here is that in programming, you have these things called types, right? So we already know what a variable is, right? So a variable speed, if you write it in JavaScript doesn't care whether it's an integer or a float or a decimal. It's just a variable. Everything's a variable. Variable speed can even become text in JavaScript. It doesn't care, even if it breaks. You can let it, So, but in C# in proper programming, variable speed, which is here, it's 1 currently. You have to say what type it is. So this is how you do. So this is how you type a variable. First you do the type. So first is the type, then the name equals the value. So in this instance, we do float speed equals to 1f, something like that. And then if you want to put public before this, you can do public. The public float speed is equal to 1f. It's no longer not this var thing is one of the most sickening, lazily designed things in the world that create bad programmers everywhere. But I just want you to understand why you have to define what type of variable that you're going to be using. So if it's a float, you're going to do float speed is equal to 1f. If it's an int score, you do int score is equal to 5 or whatever. So it always has to be defined. And now I'm going to show you what that looks like over here. There's a few other types like string. You may already know what that means. String my name, right, is equal to quotes delete. So this is a type of variable, the type of string that stores text. These are data types. There's really only a few. There's like floats, integers, strings. Now remember vector 3, what we were talking about earlier? So vector 3, it's a type that comes with Unity. But what that vector 3 basically is 3 floats in it. You have, x, y, and z. Each of these is a float. So it's nothing like, revolutionary. Vector 3 is just like an easy way to refer to just an x, y, and z, which is basically just 3 floats inside of it. So it's not really a new programming type, but it is a specific type that's used very often in Unity, and they've just made it part of it because you just use it so often, Vector 3. You don't need to write your own 3 float storage thing. It just doesn't make sense. So you have floats, you have ints, you have strings. For the most part, I think this will pretty much cover everything that we're going to do today. But in the same way that you write these, you write the same thing. You write vector 3, and then something like position, and then that's equal to, and then you type that vector 3 the way it expects to be typed, or whatever. But enough whiteboard for now. But I just feel like that's important for everyone to understand. Now, our script here, transform.position, is equal to a new vector 3, 0, transform position on y. Now, this will work. I'm going to show you another way to write this. So we're going to write this script in 3 or 4 different ways. This is going very fast. It's our same problem that we had earlier, is the time delta problem, right? So, we need to multiply this 1f by the time delta in order to slow it down. But before we do that, let's make our public speed variable again, just like how we did in our other script, right? So here's what we're going to do. So all the way here at the top, but still inside the class. So not completely outside of it. Start typing like this. So public float my speed is equal to 1f, semicolon. Semicolon you always put at the end of every line, at the end of a statement. Semicolon basically ends that statement and then lets you basically write the next statement after that. So public float my speed is equal to 1f. And then take this my speed and just replace it down here. Instead of plus 1f, you're going to do plus my speed. And then to finish this off, plus my speed times time delta time. You'll notice how it auto-completes. So the moment I start typing time, see time is right there. Then I press the dot, and then it's going to show me all the things inside of time. Delta time is right there. And you can always just double click it there and it'll auto-complete for you.
Mike's saying I have compiler errors.
Let's see. It's usually something very simple, like maybe you forgot a semicolon, misspelled something. So it's your, you gotta put a comma. Yep. Yep. Oh, you have to say. They usually tell you. See. Usually it says. Yeah. So now this will do the same exact thing. And if you have your script, just make sure you get rid of that old JavaScript from your ball. Everyone make sure to do that. And put the new script that we just wrote in there. And you'll see that it does the same thing. So now, this is like not the best way to animate something in, the up direction, but the reason why we're doing it like this again is because I'm literally just trying to show you the exact same way we did it in JavaScript. We're doing it in here, but in the C# way. Now, say you just Googled this, right? And maybe you never took this class. You just have no idea I'll do this. And you just Google something like move transform unity. Or, you know, even more vague, like move object unity. The same result will show up. You don't even have to Google move transform. See, I just Google move object unity. It says like plain English as you can get. Like say you just got amnesia after this class and you don't know how to find ThoughtWorks anymore. You forgot my email. You lost like all semblance of knowledge of any of this. You just want to move an object in Unity though. Still, you remember Unity. You just Google move object Unity. The first result is going to give you the transform translate function. So if you click right there, usually defaults to C#. And it has a little code snippet right here on update. See, all this stuff you can ignore. See this? I know it looks like very bulky and stuff. It just shows you that because that's how it is for you. See, it's always has this using, you know, Unity engine, business, and all that stuff. So usually when you look at these code snippets, it's the bulk that you want is actually inside here. So it's this what's happening in update. So and here what this is doing, it's actually translating forward and upward at the same time. So it's kind of doing diagonal. But we actually just want one of these, right? So say you just copy something like this, or you type it out right in here. I hate that so much. It's like Unity's been having this bug for so long where you just cannot copy and paste into it. Not yet. I don't know why. Okay, just type after me. So type like this: transform dot translate it has to be capital T for the second one. Just how it is. Usually most things are capitalized when it comes to like a function. So like transform.translate, and then it wants the translation. So since we're going up, you could type vector3 dot up like this. So transform translate basically does this in a simpler way. So instead of modifying the position and then making that equals to something, you're just using this translate function, which basically does that for you. And all you have to do is give it a vector 3. So you give it like an x, y, and z. Now you could type this like this, right? You can also type this like this: transform translate, and then you want a specific vector 3 maybe. You type new vector 3 because you're just creating a new one right now, and you do 0 and x, 1 f and y, 0 and z, and that's basically the exact same thing as vector 3 up. A new vector 3 with just the y in 1 is basically same thing, going up. So it's another just same way of doing this. But you know, I'm going to get rid of the second way because the first way is the more proper way of doing it. And if you just go ahead and just comment out this other one too, so we're not going to be using this one, just comment it out, but just keep it there for yourself so you can see the different way to do it. So the other thing now is, again, it'll probably move way too fast. So let's times this by my speed, and then times that by time delta time. So you can multiply vector 3s. That's one of the best things about vector 3 being a specific thing, is because when you multiply a vector, it multiplies each individual coefficient. So x, y, and z, they all get multiplied. So it's very handy to be able to just multiply and add vectors like this. So if we just do this, look at our project again, we're just gonna be doing the same thing. Ball's just gonna take off. Okay. So the last thing to have our script recreated is our little if statement, right? It works exactly the same. Right above this transform translate, you write if, and then open parentheses. If what? If input get mouse button, and then see when you open the parentheses, see what it says here? Int. It wants an int button. Returns whether the given mouse button is held down. It lets you know what the script does, right? So basically, it's a type of int for button, meaning it's an integer, so it wants a whole number, because there can only be, it can't be half a mouse button. It's either left mouse button or right mouse button, right? It's not like trans mouse button. There's no middle mouse button. There's a mouse wheel, I guess, but mouse wheel is different. Mouse wheel is mouse wheel is a little bit different. But when it comes to buttons, they're usually an integer. So, like this. Save that. So, always remember to close all your parentheses. So you open one here, then you close one there. Notice when you click like this, see, it shows you where it begins and where it ends. When I click here, shows me where they start and where they end. So, just a quick way to just, to know. Sometimes your parentheses might start and end in weird places. So, if you're ever unsure where your parentheses opened and closed, you can always just click right next to it, and it'll kind of highlight the closing bracket. So now, if we go back here, we basically have the same exact behavior that we wrote in JavaScript, but now it's running in C#, and we're very clean now. Yes. So let's see. It's usually a typo or usually a typo. Yeah, so let's see. The problem is, so you named your script with a space. Keep in mind, don't put spaces in the name of your script. So if you go, so see there, it's together. But here, go back and just rename it and make it together. It has to be exactly the same. Yep. It has to be case sensitive as well. So just let it, it's still compiling. So just screw this up. After it does that, then yeah, now try it. What I want to do is there you go. Not clicking. It's in there. So just click the sphere, you'll see it. It's always good to just click it to be safe. It doesn't do it, right? Oh, it does it very fast.
Does it really fast? I didn't actually click it on.
No, I know. So go back to the script real quick. So I'll explain this right now. Why? The reason is because you still have the other one to do it. This if statement is only for the next line, unless you have the curly brackets. Right? But we'll get into that in a second. Did not save it, and now it will only do it all. I see Mr. over here figured out how to do right click for going down. Good. So now you can imagine, as some of our industrious students have already figured out, that you can do this same thing. You can copy this block of code and just change this mouse button to 1 for right click, and then change the speed to like a negative speed. So instead of vector 3 up, vector 3 down.
And up just means 1 and down means -1?
Basically. Vector 3 up literally means 0x, 1y, 0z. And vector 3 down basically means 0x, negative 1y, 0z. They just added it because it's just like, I know I hate like typing each time. New vector 3, parentheses, 0, 1, 0, no, close. We can just do vector up. It's helpful. So if you do this, now you have a little bit of action going on. So now you have left click and right click, up and down. Okay. So we're going to take a quick break and we'll come right back to scripting.